Okay, so the first thing we're going to look at is called a change of base formula. Again, this used to be something that we had to do with the old calculators when we couldn't write any base we wanted to. So again, with your new calculators, I know you can put this directly in your calculator, but again, that used to not be the case. And so what we're going over here is what's called a change of base formula. And again, when we look at a logarithm, the base is this number. Remember, the 4 here would be the base, the 25 is the argument. So what we'd want to do in a change of base formula is we're going to rewrite this logarithm with a different base. And so the way we do that is we pick any base we want to. So we're going to start by picking a base of 10 because that's our most common logarithmic base is log of 10. And so what we do is we put our new base in both the numerator and denominator. So I have a log base 10 in the numerator and a log base 10 in the denominator. In the numerator, we put the argument, and in the denominator, we put the old base. So another way I could find log base 4 of 25 is to take log base 10 of 25 and divide it by log base 10 of 4. And again, we can put that in our calculator either way, and that gives us an answer of approximately 2.32 if I'm rounding to 2 decimal places. So again, not real complicated, just having to remember the steps. Again, this is called change of base formula. Now again, we can write any base we want to as long as we make them match in the numerator and denominator. So the bases we normally choose are base 10 and base e because those are our most basic logarithms. All right, let's look at one more that's similar to this. Pretty much exactly the same. All right, if I'm taking log base 3 of 17, so using the change of base formulas, I'm going to put a log base 10 in the numerator and the denominator. The argument stays in the numerator and the old base becomes the argument in the denominator. So I have log base 10 of 17 divided by log base 10 of 3. And if I put that in my calculator, I'm going to get approximately 2.58, rounded to 2 decimal places. When we rewrite this logarithm, we should have log base 10 of 12 over log base 10 of 2. And if you plug that in, you should get approximately 3.5850. So if you round that to 2, 3.59. So it's the same log we had before, but now we're going to rewrite it using a natural logarithm or a log base e. So we can write that as the natural log of 25 over the natural log of 4. And again, if I put that in my calculator, I'm going to get 2.32, which is the same thing we got before, right? Because it's the same answer. We're just changing the base to anything we want it to be. And so no matter what we choose to be the base, we'll still get the same answer. That's what they're wanting us to realize here. And if we do the same thing with our old b part, so our old b was log base 3 of 17. So if you rewrite that using natural logarithms, that'd be the natural log of 17 over the natural log of 3. Which again, if you plug into your calculator, you will get approximately 2.58. So that means that your base cannot be 1 and your base has to be positive. And it's always the case with logarithms. This has to be positive and cannot be 1. The argument must always be positive. Okay, so things that we'll have to make sure we double check on. The base must always be positive and can never be 1. The arguments must always be positive. If u and v are positive real numbers, then the following properties are true. So the first one's called the product property. That means if I have 2 things being multiplied in the argument, u times v being multiplied in the argument, I can rewrite the logarithm over addition of the 2 things that used to be being multiplied. Right, you can see it again here. In the argument, I have two things being multiplied. I can rewrite that as addition over the two things being multiplied. So the product property means if I'm multiplying in the argument, I can rewrite it as addition. Right, the quotient property. Here I have the arguments, two things in the argument being divided. That means I can rewrite them over subtraction. Now the one thing you have to make sure, the numerator is always positive. You see I've got log of u is positive, and then we're subtracting whatever was in the denominator. So log of v goes in the denominator. So the product property, the quotient property, and in the power property, I've already had you be practicing it. Anytime I have an exponent in my argument, I can rewrite it as multiplication out front. Right, product property. So this one should look familiar. These two will be our two new ones. And so we're going to work with some different logarithms to rewrite them, because they don't read the directions. So the directions here tell me to write each logarithm in terms of the natural log of 2 and the natural log of 3. That means the only things I can have in my answer are things that deal with natural log 2 and natural log 3. Right? They can be raised to a power, they can have another number being multiplied, they can be being added and subtracted. But like here I have a natural log of 6, that's no good. Right here I have a natural log of 27, that's no good. So I want to rewrite these two in terms of 2 and 3. So when I think of 6, how could I rewrite 6 that involves a 2 and a 3? 2 times 3. So I can rewrite the natural log of 6 as the natural log of 2 times 3. Everybody good with that? Now this still isn't my final answer because I'm not in terms of natural log 2 and 3. I've got a 2 times 3. But here I have two things being multiplied in the argument. 2 and 3. So I can rewrite those as addition like so. So the natural log of 2 times 3 is natural log of 2 plus natural log of 3. Now my answer is in terms of natural log 2's and natural log 3's. So I'm finished. So again, you're not typing that in your calculator. You're not getting a decimal answer. You're rewriting the logarithm. That you'll have to know how to do that on your own. Any questions on A? Has anybody thought about B, how you might rewrite that? The 2 looks good. Yes?
3 make the base 3 times 9.
3 is the count. 3.
Yes. 3 times 9 would work, but then I'd have a natural log of 9. I'd have to fix it too. Right? So an easy way to do it is to rewrite 27 as 3 to the 3rd power. So we're going to write this as the natural log of 2 over 3 to the 3rd. Because 27 is just 3 to the 3rd power. I know I like powers too because I can take that power out in the end. So now what do I have? I have two things being divided in the argument. I can rewrite division in the argument as subtraction of the arguments. And again, make sure that the denominator is getting subtracted. The numerator stays positive.
Well, how do you know when to add them?
When my arguments are being multiplied, I can rewrite it over addition. When my arguments are being divided, I can rewrite over subtraction. Those are the rules we just looked at. Okay? Now, I'm still not finished because I have a power of 3 that I cannot have. I can rewrite the power as multiplication out front. So this becomes the natural log of 2 minus 3 times the natural log of 3. Now my answer is in terms of natural log 2's and natural log 3's. Okay, what did we get on A part? Let me call on somebody. Let me use the whole. Pick a number, 1 through 5. It's 3. Pick a number, 1 through 3. It's 1. Huber. Don't know? So, that. Tell me, Joe, how'd you get that?
Put your phone on.
Well, it'd be, product property
Okay.
and 3 times I squared.
Okay, so 75 can be rewritten as 3 times 25, right? And 25 is the same thing as 5 squared. Like it?
And,
So now you've got arguments being multiplied, which means we can rewrite it over addition. And then you have a power that we can rewrite as multiplication out front. Questions? So what about B part? How can I rewrite these in terms of 3 and 5?
1, 2, 3 squared,
9 is 3 squared,
and 5 cubed,
and 125 is 5 cubed. I like it.
2. I forgot how to read it.
So because right now my argument's being divided, I can rewrite it over subtraction. So this would be log base 10 of 3 to the second minus log base 10 of 5 to the third.
Once you put those up front.
Yeah, and then move the powers out front to being multiplied. So this would be 2 times log base 10 of 3 minus 3 times log base 10 of 5. Hey,
Log natural 2 plus the natural log 5.
natural log of 2 plus the natural log of 5. If you've got it the other way, that's fine. Natural log of 5 plus natural log of 2. Same thing. Don't need to go over this one. B part. What do we get?
Natural log 5 minus 5, natural log 2.
That's correct. 32 can be rewritten as 2 to the 5th power. And then you bring the 5 out front. And again, because the arguments were being divided, that means I'm going to subtract. So this is basically a property that we're going to try to prove. The way we prove properties with an equal sign is we're going to manipulate one side until we make it look like the other side. So our goal is to either pick the left side and manipulate it to look like this, or we're going to pick the right side and we're going to manipulate it to look like the left side. So what I typically say is look for the side that you think is uglier, it's more complicated, and then try to rewrite it in terms of the easier side. So when I look up there, I think the left side looks uglier. You got a fraction in the argument, you got a negative out front. So I'm going to take the left side, I'm going to use all the properties of logarithms I know, and see if I can make it look like the right side. Okay, that's my goal. So we're going to start by rewriting what's on the left. Negative log base 10 of 1 over 100. Okay, so what are some things we noticed that we need to do to make it look like the right side? Well, I need to get rid of this fraction in the argument. Right? This is kind of pointless. So how can I rewrite this so it's no longer a fraction?
The reciprocal multiplied by the reciprocal.
So I could move the 100 to the numerator, and that would change the sign of the exponent. Right? There is no exponent right now, so there's an understood power of 1. And then if I move that power of 1 to the numerator, it's going to become negative. So this is 100 to the negative first. And then again, when I multiply that by 1, which is already up there, that really does nothing. Right? Multiplying by 1 is pointless. Okay, so we're closer. But now what? Now I have all these negatives that I shouldn't have. Well, now I have a negative out front of my logarithm. So I can move it to an exponent of the argument. Right? Working backwards. The opposite of the power rule. So negative out front can be rewritten as a power of the argument. So now I have negative log base 10 of 100 to the negative first. And now this is going to be raised to the negative first. See how I've moved the negative from out front to the power. And now my argument has a power raised to a power. So how do we simplify a power raised to a power? You multiply. So now I have log base 10 of 100 raised to the negative 1 times negative 1 is positive 1. And raising something to the first power, I don't even have to write that. So now I've taken the left side and I have made it look like the right side using the properties of logarithms. Basically a proof is what that is. Okay? Do we have this one? Anybody? So again, I'm going to pick the left side because I think it's uglier. I'm going to try to rewrite it to look like the right side. So first thing, fifth roots. Logarithms and roots don't work very well. So fifth root, how's another way I can write fifth root? No, it's close.
Negative 1/5.
No, that's farther away.
It's like 7 to 1/5.
Yes. Anytime I'm taking a square root, so like this, the square root of x can be rewritten as x to the 1/2 power. If I had the square root of x to the third, that can be rewritten as x to the 3/2 power. Whatever root you're taking, in this case we're taking a square root, that becomes the denominator of your exponent, and then whatever power is inside becomes the numerator of your exponent. So here I had a first, let's say 1, here I had a 3, it became 3. Okay, so this can be rewritten as log base 7 of 7 to the 1/5 power. Fifth root can be rewritten as 1/5. Now, it's basically the same problem we had last time. Log base 7 of 7. Those are inverse operations. That cancels, which leaves me with 1/5, which is what's on the right side. Where you could have moved the 1/5 out front, being multiplied, and then dropped your exponents. Because again, what's a logarithm ask? It says 7 raised to what is 7 to the 1/5? Well, that's going to have to be a 1/5 is my answer. Expanding our expressions and condensing. our expressions. So if it tells me to expand it, what do you think that's going to mean? I'm going to write it as multiple logarithms. When it tells me to condense it, that means I want to write it as a single logarithm. So these first two, they're already written as single logarithms, and they want me to expand them. That means write them as many different logarithms as we can. So what's happening here with A? Well, my argument has three things that are being multiplied. 5 times x cubed times y. Multiplied in the argument can be rewritten as addition over logarithms. So this is log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Then there's one more step. Get rid of the exponent. I don't like an x to the third, so I can bring the 3 out front as multiplication. So this is 3 times log base 4 of x plus log base 4 of y. And I'm done. Any questions on A part? So again, we're just right now working on expanding. Write it as multiple logarithms. Now B part can be a little tricky if you mix up your rules. So let's get this started first. The first thing I see, so again, there's more than one way you can start this problem. Don't think just because I start it one way, you have to start it that way. The first thing I see is division of logarithms. So I want to rewrite that division as subtraction. So I have the natural log of the square root of 3x minus 5 being subtracted by the natural log of 7. Questions about that part? Logarithms, we never want to have a root, because they don't mesh well with logarithms. But exponents do. So we want to rewrite this root as an exponent. So a square root can be rewritten as raised to the 1/2 power. And notice I've got my argument in parentheses. That lets me know I'm raising all of that to the 1/2 power. So you have to make sure that's included in parentheses. Now I have an exponent of an argument I can rewrite as multiplication. So I have 1/2 natural log of 3x minus 5 minus the natural log of 7. And now same thing, make sure you still have parentheses around that to let me know I'm taking the natural log of all of that, 3x minus 5. Now, can I simplify this?
Yeah.
To what? Do we have a rule for subtraction in the argument? It's not. Okay, that's what people will get confused. That's why I asked that. Because people will think, well, because our rule is if we're dividing in the argument, like we were here, we can rewrite that as subtraction of logarithms. But if you're subtracting in the argument, you're subtracting in the argument. There's nothing you can do. Okay? There's one more thing we could do because this part is being multiplied 3 times x, but it's not worth the problems that it would cause us. So we can just leave it like this. So again, subtraction in the argument does not simplify. we finished with this one? So the first thing that I did, I rewrote the division. So now I have 4x squared in my argument minus log base 3 of the square root of y. Is everybody good with that? Rewrite division over subtraction. Now the thing here is, what's being raised to the second power? Just the x. The 4 is not part of it. So all of that's not raised to the second power, only the x is. So what's happening here is I have multiplication. 4 times x squared, which means we need to write that as log base 3 of 4 plus log base 3 of x squared. And then the square root of y, we want to rewrite that as y to the 1/2 power. How many of you just moved the 2 out front? Okay? Do you see why you can't? You see why you can't? Because the whole thing is not raised to the second power. Not the whole argument. Only the x is raised to the second power. Wake up. I knew you were normally late, but I didn't know it was because your alarm was so late. Okay, is everybody good with that? Everybody understands why you can't move the 2 out front? Now we can, though. Now we can, because the entire x is being squared. So now I can move that out front. And then the entire y is being raised to the 1/2. So I can move it out front. Now we want to condense logarithms. That means I want to take these that are written as multiple logarithms and rewrite it as a single logarithm. So in the end, I'll only want one logarithm in my answer. Let's start with a part. So a is 1/2 log base 10 of x plus 3 times log base 10 of x plus 1. Okay, so if I'm going to rewrite these as single logarithms, I need to get rid of all the numbers out in front of the logarithms. So I've got the 1/2 power and a 3 power that I'm going to move to the arguments and turn them into exponents. So now I have log base 10 of x to the 1/2 plus log base 10 of x plus 1 to the 3rd. So I'm moving those products up to be powers. Yes?
Is the whole x plus 1 being raised to
Yes, the entire argument is being raised to the 3rd power. Now what do I have? I have 2 log base 10s being added. So I can rewrite addition as multiplication of the arguments. So I now have log base 10 of x to the 1/2 times x plus 1 cubed. Now I've rewritten it as a single logarithm. So I'm finished. Okay? Some books may want you to rewrite that 1/2 power as square root of x. I don't care. Right? You can either leave it as 1/2 or you can rewrite it as a square root. I don't care either way. I typically leave them as 1/2s because I like to deal with exponents with logarithms more so than I do with radicals. Any questions on A part? Condensing logarithms. Rewriting it as a single logarithm. B part. 2 times the natural log of x plus 2 minus the natural log of x. So I need to get rid of that 2 in front of the first natural log. So that becomes the natural log of x plus 2 squared minus the natural log of x. Now then, I have subtraction of logarithms, which means I can rewrite that as division of my arguments. So I have the natural log of x plus 2 squared divided by x. And I'm going to put all of that in parentheses to show that is all part of my argument. And I'm finished. And then C part, I now have 1/3 times log base 2 of x plus log base 2 of x minus 4. And then a bracket. Okay, so for me, because I've got those logarithms in brackets, I'm going to try to simplify inside the brackets first. Because it's all being raised to the 1/3, it'll be easier to move the 1/3 at the end. So I'm going to do that. So I can simplify the addition of logarithms by multiplying my arguments. So I have 1/3 times log base 2 of x times x minus 4. Now, you can distribute here if you want to, or you can just leave it. I just leave it because why do more work than you have to? Now move the 1/3 up top as an exponent, and I'm left with log base 2 of x times x minus 4. But then all of this is being raised to the 1/3 power. So you have to make sure you get your parentheses right to show that it's all being raised to the 1/3. If you don't have two sets of parentheses, then it'll only look like you're raising x minus 4 to the 1/3. So make sure you have it all in parentheses and then raise it to the 1/3. Otherwise, it will be incorrect.